Imagine for a moment that you are on the edge of your own solar system, floating in space, as far as we can go with our technology. Behind Neptune is Pluto, a dwarf planet shrouded in mystery that was once considered one of the 9 planets. Despite the decline of the debate, the name Pluto still evokes wonder in the human mind. But is this tiny world at the edge of our solar system even smaller than some have thought? In fact, thanks to advances in space, including the James Webb Space Telescope and the New Horizons project, scientists are uncovering surprising new evidence that may make us rethink power of the planet Pluto and others for our understanding of planetary thrust. First, the universe is an endless process of explosion and creation. Could Pluto be one of the many celestial bodies that play an important role in this cosmic mystery? Pluto's story has changed a lot over the years, especially since its classification in 2006. However, that is no longer the case. About a decade ago, the International Astronomical Union, IAU, reclassified Pluto, demoting it to a dwarf planet. The decision was met with widespread controversy and sparked debate in the scientific community and the public, but now, fast forward to today, the IAU is looking at this controversial issue again. Game changer in this conversation? None other than NASA's revolutionary James Webb Space Telescope. With the most powerful telescope ever launched, James Webb has captured new images of Pluto that allow us to look at this distant planet in ways we never thought possible. These sharp and clear images will rewrite the textbooks. Could Pluto, relegated to a common dwarf planet, be on the verge of regaining its planet status? For anyone interested in the mysteries of the universe, this is a good time to dive into this story. In fact, if you want to keep up with the latest discoveries of the world and beyond, now is the time to hit the subscribe button and join us on this amazing journey. Enjoy, share and press the notification bell to stay informed, because the world never stops expanding and so does our thirst for knowledge. Since the Apollo 11 mission first landed man on the moon, man has come a long way. But the vastness of space leaves us with an endless set of unanswered questions. One of the most interesting is the appearance of distant celestial bodies such as Pluto. This is where NASA's flagship James Webb Space Telescope program comes in, opening up a new world of space exploration. Building on NASA's previous achievements, this telescope is unlike any other. The main goal, to uncover and explain the mysteries of the world, unlocking the visions of the past, while the sight extends into the future. As humans, we only know where the universe came from and our place in it. How did our solar system form? How did life originate on Earth? For years, scientists have been looking to the stars for answers to these fundamental questions. The James Webb Telescope, however, looks beyond our known boundaries to uncover secrets not only about the past but also about what lies ahead in the farthest reaches of our solar system. Yet, despite all the advanced technology and theories, one of the most pressing issues that continues to captivate the minds of astronomers is the so-called Pluto question. Ever since its demotion to dwarf planet status, Pluto's classification has remained a hotly debated topic within the field of space exploration. And thanks to the James Webb Telescope and the invaluable revelations it has provided, we now have an incredible wealth of data to analyze, which could finally answer this lingering question: is Pluto really a planet after all? The $11 billion investment in NASA's space research has already led to a number of groundbreaking updates, particularly when it comes to Pluto. Science textbooks are also being updated to reflect everything we've learned from recent missions and observations. In fact, with new images taken by NASA, the chances of Pluto returning to planet status are increasing. But the story doesn't end with Pluto's controversial reclassification. In fact, it's only the beginning of a broader discussion of how the planets are defined, and what the universe has yet to reveal. The IAU first questioned Pluto's status in 2006, and while some accepted the change without question, others wondered if the decision was too soon. It is important to note that the IAU's decision was based on a set of rules and criteria that existed at the time. But these rules were created with little data. The James Webb Telescope has provided us with visual and objective evidence that supports our understanding of Pluto. One of the first human encounters with Pluto was through NASA's long-running New Horizons program. In July 2015, the New Horizons spacecraft completed its first flyby of Pluto, giving humans the first close-up images of the dwarf world and its moons. These groundbreaking images show Pluto in stunning detail, showing its surface, atmosphere and 5 moons, including its largest, Charon. This mission is very important as NASA explores the Kuiper Belt, the farthest region of space where Pluto resides. The Kuiper Belt is home to many small, icy bodies that were unknown until recent years. The success of the New Horizons project opened many opportunities for NASA to study this distant part of the solar system, revealing new perspectives not only about Pluto, but about other bodies of the sky in this cold. This discovery was a turning point in the study of Pluto and forever changed our view of this distant planet. The encounter with Pluto almost 9 years ago, along with the new technology of the James Webb Telescope, has paved the way for other exciting discoveries. Arguably we are closer to fully understanding the dynamics of the solar system, but questions remain. One of the amazing things about the New Horizons mission is that Pluto is not a single, static object. However, the world is dynamic and has its own unique geological processes, some of which are not fully understood. Sharp images taken by New Horizons reveal new information about Pluto's surface, including an interesting feature called Sputnik Planitia. This huge nitrogen glacier with an area of thousands of square kilometers immediately attracted the attention of the world. Why does Pluto have the shape of a heart? What about the internal processes of the dwarf world? Sputnik Planitia is just one of the features on Pluto that have sparked scientific interest. Perhaps even more fascinating is the fact that Pluto's axis of rotation has undergone significant reorientation, a phenomenon that scientists refer to as precession. Prior to the New Horizons mission, NASA had no knowledge of this reorientation. It was only through the mission's detailed observations that scientists discovered Pluto's rotational axis had shifted, a finding that has profound implications for our understanding of how the dwarf planet interacts with its environment. This reorientation is believed to be influenced by Sputnik Planitia itself, which exerts enough gravitational pull on Pluto to alter the planet's rotation. The exact mechanisms driving this shift are still being studied, but it appears that the dwarf planet's internal structure, including its core, may be playing a key role. Pluto's heart-shaped glacier, far from being a superficial feature, might hold the answers to some of the most perplexing questions about the planet's geological evolution. As impressive as these findings are, they are only the tip of the iceberg when it comes to Pluto's mysteries. New Horizons also revealed that Pluto's surface is covered in a thick layer of ice, estimated to be 4 kilometers thick. This ice layer, along with tidal currents from Pluto's largest moon, Charon, may contribute to the planet's complex climate. Scientists continue to study these phenomena to better understand how something so small and so far away can exhibit such dynamic properties. Additionally, recent observations have shown that Pluto may harbor an ocean beneath its icy surface. It is believed that there is a subterranean ocean, a vast ocean of water hidden beneath the outer ice of the planet. The presence of this ocean has a profound impact on science and opens up exciting new possibilities regarding life beyond Earth. Could Pluto, once thought to be a barren, icy world, still support some form of microbial life beneath its icy crust? The possibility of an ocean on Pluto has scientists rethinking their understanding of Earth's history. This ocean is made up of solid ice from the heat generated by Pluto's core and its interactions with the moons. The existence of an ocean beneath Pluto's surface could provide important clues as to what other icy worlds, such as Europa and Enceladus, might be like beneath their outer edges. The discovery of liquid water on Pluto is a game-changer in the search for habitable worlds in the solar system. One of the most surprising discoveries made during the New Horizons mission was the thin, fuzzy shape around Pluto. For decades, scientists have suspected that Pluto may be thin, but detailed observations from New Horizons provide conclusive evidence. This gas, which is mostly nitrogen, methane and carbon monoxide, is more than 1,600 kilometers above the surface of the planet and is constantly rotating as Pluto moves in its circular orbit around the Sun.